Hello everyone, especially to my physics teacher. Hello po sir. My name is Marjo and today we'll be talking about 4 topics revolving around physics, which are the measurement, motion in 1D, motion in 2D, and Newton's law. For the first topic, we'll be talking about the measurement. So, let us get on with it. As you can see on the board, these 3 are the 3 basic measurements, namely the length, mass, and time. Length is the measurement of distance, mass is a measurement or amount in body, and time is the measurement or interval over where change had occurred. And for these 3 measurements, they have their own standard units, namely the meter, kilogram, and seconds. Let us now move on to the conversion factors and how to convert them to one unit to another using dimensional analysis. Here are the conversion factors for length that we will be focusing on using for this video. Besides from what I mentioned earlier for mass and time, in this video I'll be focusing on the conversion factor for length. Take note of these 4 conversion factors. Before moving on to the conversion using the dimension analysis, let me explain what dimension analysis is. Dimension analysis, in simple terms, is the problem-solving method that uses that any number or expression can be multiplied by 1 without changing its value. To perform the conversion, we must have the appropriate conversion factors earlier on this video. Then multiply the values together, then we can cancel the units all in one, and then we can have the outcome. Let's demonstrate. Let's have our first problem. What is 150.0 meter in centimeter? Earlier, we already have that conversion factor. Let's use that. 1 centimeter is equal to 0.01 meter. Let's use the dimensional analysis method. We write the original value, which is 150.0 meter, and then we multiply it with this, the numerator and denominator. With the rule of dimensional analysis, we always put it in the opposite of whatever the original value is, because sometimes in physics there is a value below the original value. Just put in mind, in whatever side the original value is, always put in the opposite. So for this example, we put 60 seconds here, and then for example maybe it wanted 1 minute. That is how it is. But let's go back to the original problem. Now, we put the same value in the denominator or the opposite side of it. Let's put 0.01 meter, and then the desired outcome, which is centimeter, for 1 centimeter. Let's multiply it on the calculator, and then we're gonna have our outcome. 150.0 times 1 divided by 0.01 meter. In centimeter, we have as an answer of 15,000 centimeter. Let's have another problem. Let's have our second problem. Well, as you can see, we don't have a direct conversion, but we can still use it because there is similar units that we can still use. However, in this case, we can use the continuous dimensional analysis. Let's do that. Let's put the original value, 2.30 miles. Let's put on the opposite side of it, which is 1 mile for 1.609 kilometer. And then 1 kilometer for 1,000 meter. Oh, if I wasn't clear enough on the first problem, this is what is supposed to happen. A cancellation of units. That is why the remaining unit will be suppose our desired outcome. Let's hit on the calculator, and the answer is 3,700.7 meters, or you can round it up to 3,701 meter. Either way, it's both correct. Or if your teacher wanted to be exactly 3 significant figures, you can also do that, which is the answer is 1, 2, 3, 3.701 meter. Wait, let's not forget the important sign. Times 10, 3, since we moved 3 parts. Then that's your answer. 3 possible outcomes on whatever your professor asks you to have in your problem. Let's move to the second topic, which is motion in 1 dimension. Motion in 1 dimension, that implies motion moves along in a straight line or in a single direction. Let's have an example, and for the equation, it is now posted on the screen. Let's use that. Here's our problem. The car has a speed of 60 miles per hour, and the problem is, what is its final speed when it reaches 120 kilometers? Now we already noticed that it does not have the same unit. This one is miles, this one is kilometer. We're going to use the dimension analysis and an equation to find the speed. Speed means time. What is the overall time when it already reaches to 120 kilometers? Let's do that. These are the following factors that are mentioned, and this is the equation to find the distance, or in this case, we're gonna use it to find time. But first, let us convert 60 miles per hour to kilometer per hour. Let's do that. Let's write the original value. 60 miles per hour, and we're gonna convert to kilometer. Earlier, if you remember, 1 mile is equal to 1.69 kilometer. Let's use that. Let's put the same value, 1 mile on the denominator, and then the desired outcome, 1.609 kilometer, and the answer is 60 times this 96.54 kilometer per hour. The hour is still the same since it only requires us to change its kilometer. So let's not do any changes for the time. 96.54. Let us note 96.54. Let's Note that as an answer. 96.54. 96.54 kilometer per hour. Let's note that. So the answer is, let's put the answer here. 6.54 kilometer per hour. Now let's go and find time. Oh, I forgot to write here that the distance is 120 kilometer. That was the whole point why we want to convert it to kilometer per hour. Now let's use the equation that we have. X, or the distance, is equal to velocity initial, and time. Forgot to write it down that our distance, or the X, is 120 kilometer. That was the whole point why we want to convert 60 miles per hour to 96.54 kilometer per hour. Now let's use this equation to find time. X is the distance, velocity initial is the 96.54 kilometer, and time, which is still unknown to us. Let's put the values. Kilometer is equal to 96.54 kilometer per hour, and time. Now how are we gonna find time? We divide, or at least cancel these values so that we can find time. Or at least we're gonna substitute it to make this whole equation time alone. Let's do that. Here is 96.54 kilometer per hour. Let's get another chalk. And 96.54 kilometer per hour. This is gonna cancel out, and the remaining for time is 120 kilometer, or 96.54 kilometer per hour. Let's hit that on the calculator and let's have our answer. 120 divided by 96.54 kilometer per hour is equal to 1.24 3008, but the rounded off number is 1.24 hours. So the time is 1.24 hours. We have found time, we apply dimension analysis, and we also substitute our equation to whatever we need to find with the current equation. Let's move on to the motion in 2 dimension. Let's move on to motion in 2D. In this video, we'll be focusing on the horizontally launched projectiles. However, there is 2 types of projectiles, namely what I mentioned earlier, the horizontally launched projectile, horizontal, and the non-horizontal launch. Or in other terms, it is vertical. But for this video and problem demonstration, we'll be focusing on the horizontal launch projectile. Let's demonstrate. This is our problem for motion in 2D. A ball fell from a height of 73 meter with an initial velocity of 10 meter per second. What is the distance at which the ball landed from a cliff, and what is the time of flight? So these are the few factors that are given to us. The height of 73 meters, which is the y value, because it did say it is the height. So it is 73 meter with an initial velocity of 10 meter per second. So 10 meter per second is our initial velocity, y. What is the distance of which the ball landed from a cliff? This is talking about the launch. Wait, let me draw a diagram. Let's pretend this is the cliff. This is 73 meter. If the ball fell, which it did, this distance that is asking from us is the horizontal distance on where the ball could possibly landed. And what is the time of flight? The time where the ball landed on this horizontal distance. So let's find those factors. Here's our factors and equations that are going to use for the substitution for time and to find our horizontally launched equation. Let's get to it, shall we? From this equation, we can just derive it into this shortcut of time is equals to the square root of 2 times the height over acceleration or gravity. They're both the same, acceleration and gravity. Even if the sign had changed, these two are the same because in the vertical, gravity is present, so therefore they're still the same. So let's type it in on your calculator. 2 times the 73 meter over 9.8 meter per second squared, and our answer for that would be 3.86 seconds. This is our answer. That is the time, 3.86 second. There is no 2 there. I don't know why I put square there. And it's 3.86 second. Let's try another way. Instead of using this, you can just use this actual equation. Let's try that, shall we? Let's demonstrate on the other way besides the shortcut term to find time. So let's use this. Let's do no, that's not equal. It's supposed to be plus 1/2 acceleration gravity squared. So this is 73 meters. This is going to be 0 since in the diagram that I used here, on the maximum height, the velocity in the vertical position would be 0 meter per second. So therefore, our velocity for y would be 0. So in any case for this, it's automatically 0 even if we did find the time for that. So we are now left with the 1/2 of negative 9.8 meter per second squared and time squared. So that's how we. In our calculator, let's find the half value of acceleration of gravity, which is negative 9.8 times 1 half. It is equal to it is equal to negative 4.9 meter per second squared time squared. And this is 73 meter. What we want to do is we want time to be isolated in this spot. So what are we going to do? We're going to divide the half value of the acceleration of gravity. So negative 4.9 meter per second squared. Oh, I should mention, since it is a height and it is going down on the vertical, means this would be negative as well. So it is actually negative 73 meters. So let's do that, shall we? Per second squared. Cancel this out, which we are now left with this. So for that, in our calculators, negative 73 and negative 4.9 would be 14 point, excuse me, I had a great dinner, sorry for that, 0.9, this is rounded off, cancel the meters, which is, this is now second squared. Now we want it to be time itself, so let's square this, and the answer would be 90 is still 3.86 seconds. This is another way of doing that using the actual equation itself. So now let's move forward on finding the horizontal distance. Let's use this equation. So x is equal to, with this initial velocity, 10 meter per second, and multiply it with the time of flight, 3.86 seconds, which we are now left with 38.6. Cancel this, seconds. Oh wait, no. Sorry, I'm wrong. It's cancellation. And meters, which is now left with, cancel that out, it's actually 38.6 meters. Let's write that. So now we have found all of the required factors to find, and that is my demonstration for solving a horizontally launched projectile for motion in 2 dimensions. Let's move on to Newton's law. Just a reminder before we move on to Newton's law, in the equation that we did earlier, or the solving itself, those are favorable if the external factors like air resistance is neglected. So now let's move on to the Newton's law. Newton's law have 3 laws, namely the first, the second, and, well, obviously the third. This first is the law of inertia. Second is the law of acceleration. And the third is the action and reaction. First, the law of inertia. This states is that an object would be at rest unless an external force had acted upon it. Let's use this as an example. A wallet. This wallet rests at my hand, but if I put a force, as you can see, it fell. So that concludes it did move because of an external force. Second law of acceleration. This talks about with this equation. The force net is equals to mass and acceleration. How is it connected? Well, if we change the F net to a higher scale, or change it to a larger quantity, the acceleration also rise, because in the second law it states that acceleration is proportional to the force, well, at least in the net force. And the third, in any force of nature, there is always an equal and opposite reaction. Let us demonstrate it with a baseball and a, well, bat, with my horrible drawing skills. So let's hope that you understand what I'm talking about. This is a bat, and this baseball is here. The baseball is thrown by a pitcher, which goes to this action. It goes to this direction. Now, because on the force of, or at least on the rules of baseball, we now have to push the baseball so that we can, well, hit it, obviously, before we hit a home run for that sport. So the baseball bat will go in this direction, while the baseball ball goes to this direction. It's an action and reaction. There's always an equal and opposite reaction. Let's have a little problem solving. Concludes with the Newton's law. Here is our problem for Newton's law. How much force should we apply for a 45 kilogram object that's supposed to be for a 45 kilogram object that moves rightward with an acceleration of 15 meter per second squared? Now that force wants us to find the net force. So if you remember the equation I wrote earlier, then you already know what the answer is. So with this equation, the F net that I wrote earlier is mass times the acceleration. So let's do that. That's right. Let me get another chalk. It is a 45 kilogram times the 15 meter per second squared. Type that to the calculator, and we have an answer of 45 times 15. It is 675 kilogram times meter per second. Or, in other terms, 1 F net is equal to kilogram times the meter per second squared, and it is equal to 1 Newton. So in other terms, this is our force, 675 Newton. Now, what if the given have changed? Wait, no. Sorry, my mistake. It is 675 newtons. Now, what if we change something with this equation? What if instead of an acceleration, it mentioned that it has a constant velocity of, let's say, 25 meter per second. What do you think the F-net is? Well, now we change something with the equation. It says a constant velocity of 25 meter per second. If you remember, the F-net wants a mass and acceleration. Now, do we have an acceleration with a constant velocity? No. So therefore, our F-net is now 0. Why? Because the problem has changed into constant velocity. If there is a constant velocity, there would be no acceleration. That is all, and thank you for listening and being attentive in our physics tutorial. Bye!